Today we're diving into the powerhouse behind 45 White Oak and its massive electrical service. From the 15,000 feet of cable to the high-tech panels inside, the setup doesn't just power the house, it's the heartbeat of modern luxury. We're about to break it all down from the pole outside to the light switch inside. I have Jared from Driscoll Electric. He's gonna walk through the system with me. Let's just start in the street. We have an overhead wire in the street, a pole across the street. There's typically two options to bring that power into the property. You can go overhead and then you can go underground. Typically we're going underground. It's generally more expensive. Why is that?
Underground, because we have to run the lines directly. You have to trench obviously out all the way up to your meter socket. We have to run our pipe according to the size of the wires that are pulled. And they have to be sized properly for the voltage, as opposed to an overhead. It's generally undersized because it's in free air. You lose that advantage with going underground, but it's obviously much cleaner.
Yeah, and then typically we're bringing all of our communication cable as well in that same trench.
Correct. We'll run the communication lines for the low voltage company to pull through later.
So coming up the side of the home here, we get to our meter socket. Walk me through what we have, what we're looking at here. Obviously, understandably, this is our meter socket, but then we have, as the sticker says, they're emergency disconnects. Why do we have two of them?
So we have two emergency disconnects because the span panels are only rated for 200 amps. So we had to take our 400 amp main and split it to two 200 amp feeders going in to feed the panels individually. In the new code, we have to have our main disconnects outside, as opposed to a few years ago, they could have been inside. So we have two 200 amp mains that are individually piped down through the foundation into our trough that will individually feed our two panels downstairs.
Why has the code changed to requiring them on the outside?
I think the intent is essentially more for, in case of emergency, firefighters could come up here. They don't have to go inside and figure out where your panels are. They go right to the main and they know all their disconnects are right here.
Yeah.
So they can kill power without having to go inside.
This home is all electric. There's no natural gas. Everything is fed from the electric service. In order for them to shut the home down to make it safe, it only makes sense to move that on the outside.
Correct.
So coming up out of the ground, you know, our grade is about 2 feet low right now. So most of that will be buried. Everything is kind of temporarily put on wood blocking until the final conditions are in. But from here, we're going right on the inside, right?
Correct.
So why don't we go into the mechanical room? Have you ever filmed anything?
No.
One of the things with the mechanical room, Jared, that we were really particular on this project is making sure everything was in one spot. So as you saw, as we walked up the side of the home, the electrical service is on what I call the business end of the house. Everything is coming in and out and packaged on one side. But we're standing in front of the garage right now, and you'll see as we walk through this space, the mechanical room is actually pretty hidden. If you walk in this home, you see the garage, you see all the living space in the basement, you almost don't even know that there's a whole other room we very much intentionally put in the back there to house all of this. All right, so we're on the other side of that foundation wall with these panels. One of the things I was always told, especially when we're going underground, is once you're coming in, like, get the panels as close to that as possible. Why is it important, or at least encouraged, to get the panels as close to the meter as possible?
It's very similar to outside why we have the disconnects. It's all for emergency safety. They know that side wall where the feeders come in, the panels are located, you know, directly behind or very close to where the power comes in. Try not to run your feeders, you know, through the space into a different area where now they're coming in looking here and the panels aren't here. It's all referencing code.
Even from a cost perspective, now you're not running essentially a large feed all the way to the other side of the house.
Correct.
Again, this is part of, you know, thinking about how we're going to lay this out, thinking about where the mechanical room is, thinking about where everything comes in on the home. I'm going to keep calling it the business end of the house. Span panels, 200 amp panels, that's what they're designed for. We have two of them because we have a 400 amp service coming in. The 400 amp service was based on a load calc. So generally speaking, what is a load calc for a home like this?
So you're going based off of all the utilities you have, appliances, you have kitchen, general space, lighting, and kind of everything gets added together, and there's percentages you use to find draw based on what's going to be used at what times. You don't really, it's not like you take everything you have and add it up. It's all split to be, obviously, like, your heat's not running when your AC is running. So you pick the larger of the two, and everything gets split up like that. Obviously 400 amp was sized right for this property. It's a big house. With the 400 amp service, it seems a little small, but it's because everything in here is so high efficient.
When we were sizing the heating and cooling equipment, we had this massive cooling load, and we were able to reduce that by 50% by making a couple decisions. We'll talk about that in a future episode, but that's a large reason why we're able to stay within that 400 amp. It's important to go through that exercise. What I've seen in the past is you just throw a giant service at it and you know you're overcompensating for what the home requires, but then you're just overspending and being less efficient with resources and frankly money.
Right.
This home is being prepped for solar on the roof, and in the case the client that buys this home wants to put solar, have battery backup, these are really like, that's where these things shine. It has full low voltage control system on it. You can control it on your app. You can shut things off, circuit by circuit, room by room, have full control any electrical service in the home, which is really important if you have an outage, save that stored battery power and not have everything running that you don't need running. And the one question that comes up all the time is like, that's fine, like, but you're just adding tech to an area that you don't need tech. In a lot of cases, I agree with that. The benefit of using span is that this just uses regular breakers. Is that right?
Correct. So you can dumb these panels down to work as a conventional load center. So there's regular breakers in here. You can use any standard breaker pretty much, Eaton, Murray, Siemens, whatever you got. And you can flip them individually as you want. If you were to lose, the Wi-Fi or the low voltage, everything will work conventionally.
Yeah,
it's never going to get phased out, I guess.
That's the fear, is that now I'm stuck with a panel that is only controlled by them, and that's not the case. Like you said, it operates as a typical load center. Looking at this wall, you guys did a terrific job. Number one, you have these two troughs on top and bottom. What's going on here?
So the reason we have two troughs, it's kind of interesting. Generally what we'd have is a top trough. Our feeders are coming right through the back of here, and they're winding down into the panels individually. Generally, all of our branch circuits would come in the top as well, and we would do separate pipes down into the panels to feed our breakers. Mm-hmm. With these span panels, there's antennas up on the tops that take that space away. So we only have space in the center to bring our feeders through, which means we had to game plan to how to make our branch circuits come down nice and clean and keep this place looking nice. So we added this lower trough for all of our branch circuits to run down the wall behind into this lower trough, where from there we'll branch up and feed all of our breakers.
So all of the circuits coming out of this panel end up here, and that's what we're seeing head up in that direction there.
Correct.
Pretty basic question, but you have white, yellow, red, black. What's the difference between those wires?
Yeah, it's color coding for the gauge of the cable. So our whites are 14 gauge, yellow is 12 gauge. The code's changing again, so 14.3 is now going to be blue.
Okay.
12.3 I believe is now red.
Okay.
We have our 10, which is pink. 10.3 is pink now, so
okay.
Those are going out to our wall ovens. And then those black cables are all 6 gauge for the condensers and the cooktop.
I remember early on, like, you're asking all of these questions, like, what are you using for your appliances? What's the heating and cooling equipment? This is really where it becomes increasingly beneficial to know what you're getting into, again, to make sure that we're operating efficiently and not oversizing something or overcompensating. Is there anything else in this space that's important to you dealing with a mechanical room?
Basically just clearances. Like, as you can see, this room is huge, so we need clearances left and right of our panel, in front of our panels, and directly above. So this ductwork's running right in front of our trough. It couldn't be running right over our trough.
Got it.
So everything's spaced off of our panels. This is obviously going to get the drop ceiling. So our trough will be surface mounted. You'll be able to service that through a drop ceiling later if they end up adding anything.
Yep.
Having the troughs makes it incredibly easy to add stuff in the future. You don't have to snake through the walls. It's all open in the back.
That was a big reason why we built this room the way we did. We wanted it to be large. We wanted everyone to have their kind of dedicated space, but also make it serviceable. Like, make it so when you come in service this home and the client wants to add something, change something, you know that you can get into it and keep the room looking nice and sharp. Right. I mentioned it, but we're prepping for solar. What does that mean for you guys?
So in prepping for solar, all that we can really do is run that pipe. So generally when you see solar panels, you see that 3/4 EMT running down the side of the house.
Yeah, not here.
Obviously with your siding, you don't want any pipe running down the side of the house. So we went ahead and we ran an oversized 1¼ EMT. We ended up stopping at this hallway just until the ceiling gets framed.
Yep.
But you can see the beginning of our 1¼ EMT right here that runs directly through the basement ceiling, ends up poking up through our chases and goes all the way up to your roof access panel.
So EMT.
EMT.
What does that stand for?
Electrical metallic tubing.
The challenge with prepping for solar and running a conduit up to the roof is how many times it bends. Is that right?
Correct. So we can't have anything more than 360 degrees of bends before we hit a pull point. So obviously that would require a can, and that can would need access. So then you have access panels in the walls, essentially stuff that you don't want. So we found a nice clean chase where we could go up, and I believe we only have 220 degrees of bends right now.
2 weeks ago we were chatting and I was like, hey, we need to get permanent power on. When I was pushing you guys to get the permanent power, one of the things was like, I need the water. And you know, when you hear that, it's like, why does an electrician need water? Walk me through what you had to do in here.
Yeah, so we have to ground to the water main coming in. So I needed his meter. Generally what would happen is we jump out the meter. The meter generally comes in directly from where the water main is. So the water main's right under the stairs here. Generally what would happen is the meter would go right there, and I have to have a continuous line out to my, my main that is going to ground the beginning and end of the water meter. So if they come and swap that meter out, the bond stays through the cable that jumps out both sides. Here it's a little interesting because you have all this piping before the water meter. So that made it a little tricky for me. So I ended up having to run my cable down to the main disconnect for the water underneath the stairs. And that's a constant loop that comes back up and penetrates this wall and grounds the home side of the water main.
And this is what grounds the entire home, right? Like when you think about the outlet.
Yeah, this is one of our grounds.
Where's the other?
So we have 2 ground rods outside of the meter as well.
What is a ground rod?
A ground rod's an 8-foot long copper rod, I guess you could say, that you got to drive down. And we got lucky here with no ledge because you guys dug all this up for the foundation.
Because we spent 6 weeks getting rid of ledge, yeah.
Yeah, so we had nice smooth sand to drive down into to hit our ground rods, and everything went smoothly. If you end up hitting ledge, there's different ways you can do it.
Sure.
You can drive down at a 45. Or you can actually lay it flat, I believe, 2 feet in the ground.
The other option is you can actually tie into the rebar structure of your foundation as well. Yes. Which, fun fact, I prepped for that twice, and both times it got cut off. Yeah. But why don't we go upstairs and start walking through some of like the specifics. And why don't we start with the kitchen? I feel like the kitchen is one of the areas that requires the most attention. There's that pink wire, the black wire, primarily set for appliances. Walk me through kind of what we have going on this wall. Like, why is this a whip, and what determines where they go and things like that?
Yeah, so we're landing all of our cables that are going to appliances in general locations right now to accommodate for how the cabinets end up laying out. Because we can measure off of the plans, and the plans are ever changing, just like our code.
Not ours.
So we ended up leaving whips in general locations for all these kitchen appliances. We have the little grill, we got wall ovens, cooktops, more griddles, and these will end up getting stubbed out through the sheetrock into the cabinet space, where then we can terminate them in the proper locations, cut down this slack, and make all of our connections nice and neat in the back of the cabinet.
It is nice to have that ability to make that adjustment on the finish, right? I know we've all done it. We've put an outlet where we're supposed to for a refrigerator, and you go to push the fridge in, and the plug's preventing you from getting that set all the way in, especially on a lot of these integrated built-in appliances. One of the things that we did on this project is we have our service cavity wall. So our exterior wall is a 2x6 wall, fully insulated. Was adding the service cavity helpful to you guys? Was it more complicated?
It's very helpful because now we have a nice clean bay to run through with no insulation. So generally we do all this nice wiring, we get our inspection, the insulators come,
destroy
it, and you never get to see it. So this leaves it nice and open for everyone to be able to see. It makes it easier for the sheetrockers to poke everything out because now there's no insulation in the way. Nothing's getting tucked in the wall and forgotten about. It makes it really nice and clean.
So shifting gears, above, this is all our countertop outlets. Walk me through why we're using, number one, these boxes, but how you determine layout for something like that.
Yeah, so we have single gang boxes. Our countertop requires 2 circuits. Generally what you'd see is a feed coming into this first box and then an out of that box. We generally would skip the second and hit the third.
Okay.
So that if you have all your appliances in one spot, you don't have them plugged into the same circuit.
Oh, interesting.
So we go every other box to accommodate future people living here using the countertop space.
So these two are never going to be on the same circuit?
Correct.
So if I blow this one with my toaster, I just move it over.
Right.
There you go. Okay.
Call the electrician, will come and get it back on for you. So we actually ended up having 1 cable at each box. We have single gangs because we're using single bocce receptacles. That plate actually ends up closing this box space up to about 1.25 inches, in which case the code requires that we only have 1 wire in each box so that there's no splice in there that you can't get at later. So all of my feeds, actually, there's 4 instead of 2 because we have 4 countertop circuits. 4 countertop receptacles. Those all go down to the trough space and they'll splice in that trough and hit breakers. Each box has 1 cable This one will get tied to that end one, and that second one will get tied to this end one in the trough, and then it's very easily serviceable from downstairs later.
Yeah, the bocce it's the 22 system, so it's just a little small circle. And when we're dealing with such a high profile kitchen and really high design, we all try to eliminate electrical outlets for the pure aesthetic of it. You know, we've worked with TrueFig, we've worked with, you know, all of these built-in receptacles, and here it really made sense. It's, like you said, it's 1.25 inches, really, really nice looking. The adjustable boxes, I've seen these a lot in remodel. What's the benefit of using something like that?
Yeah, so this gives us the ability to not have to know what your backsplash thickness is right off the bat. So if you come in here with plywood, or you add another layer of sheathing or something like that, I don't have my box space to what I think it's gonna be. I can always adjust this out to be flush with the finish.
So you're just taking a Phillips screwdriver, putting it on this screw, and this box slides in and out, and that gives you the ability to close that gap. I've done it plenty of times where you set that it's too far in the wall, and then you're buying those spacers and hoping that they're deep enough. So this is a nice benefit. The other thing about these is we don't do a lot of spray foam in our projects. I see a lot of these get installed and then they get foamed in place and you can't move them.
Correct.
So a nice benefit of having that surface cavity wall is you have the actual ability to move them in and out.
And your rock wall makes it nice and easy to have everything be clean. Nothing's getting sprayed in.
Right.
If anything was to get hit during sheetrock, I know that I can pull these cables down through the box behind the finished wall later.
That's a great point. Yeah, they're not permanently fixed into that wall.
Right.
So let's flip around. Our island is designed. We have a kitchen sink here. What is code today for island receptacles?
So I want to say the code just changed to now not requiring island receptacles again. There is a mass amendment that requires it again.
Yeah.
So in mass, we do need it.
Sure.
So what we have going on here is, because of the overhang on the opposite side of the countertop, we're going to end up having 2 service receptacles on this island, one centered up on this post and one centered up on the post to the left.
And these will be the 22 system by Bocce as well.
Yep.
We'll put them on the working side. Like you said, we have the overhang over there. It makes it difficult to meet code. Code aside, the reason that we have them is they pull out a mixer or want to make a smoothie and they have it on the counter, like on the island. I think the dumbed down version, at least that's been explained to me, is that you don't want that cable running in a way that essentially can be tripped or walk by and rip the appliance off the counter and knock your 4-year-old out.
Yep.
So getting them on this side, which again, like I'll call this the working side of the island, makes a lot of sense. You have the sink here, you're doing a lot of your cook and prep here, and putting them there only makes sense for specifically that requirement.
Stand mixers, it gets rid of people running extension cords maybe to their countertop to then work on the island, in which case you have safety issues again.
Looking in this direction, we have pantry, we have our refrigerator wall. I'm looking at this, I saw this the other day. It's super neat. Everything is running nice and straight. Everything is zip tied together. What are these and why is this important to you guys?
These are called Caddy bars. So they're spreader bars. They're adjustable to the length of the wall. They have 18-inch and 24-inch versions. You can cut them down for smaller spaces. And it just gives us a nice clean path to be able to zip tie our feeders through, because obviously I don't have enough space on these studs to staple up. So when I have a nice wall of cable, I have to figure out an alternative to how I'm going to run those nice and neat. We love to use Caddy bars. It gives you generally more space than you need for adding stuff later, and just keeping everything nice and clean.
Why is it important for you and Driscoll to keep your work nice and neat? That's one thing that I've always appreciated about you guys, is that no matter what it is, like, and frankly, like, you put a lot of pressure on us to make sure that blocking is correct or layout is correct, but why is it important to you guys?
Well, I mean, this is what everyone gets to see on our end. All of our stuff ends up getting closed up, and all you see is outlets, receptacles, switches, and everything like that. But for the whole course of this job site being open, homeowners, carpenters, GCs walking through, this is all they see. And I think it goes without saying that when you see work done like that, your contractors are doing the right thing throughout.
Another example is behind you. So I noticed as you come down out of the top plate, you have these plastic clips. Yep. I'm not even going to guess what they're called because
these are stackers. They're called
stackers.
We obviously have too many cables to be able to staple down the bay. So this is another instance of just having too much wiring with not enough real estate. So these are a great alternative to using Caddy bars, where you might not have that many cables And these will take up to 8 cables. You can double stack 14s and 12s. So then we also just go the extra little bit and throw zip ties in just to keep them all nice and neat between stackers. Because there's no staple, it's not as tight as a staple would be. It's a lot more difficult to keep them flat between stackers.
Sure.
So we just go ahead and throw zip ties just to keep it all as neat as possible.
And what's the benefit of kind of going way beyond the box and coming back into it?
So this is just a little bit of extra leeway on the finish. If anything was to change, or if this switch box ended up being on this wall, my wires aren't coming down and terminating right away to where I can't now move them. So it's all just in preparation for designers and architects to change stuff later.
We don't do that.
We don't do that either. But it just leaves you a little bit of extra slack to work with later.
What about the blocking here? Is that something that you worked with our team to make sure?
Yes. All the plans are laid out so that all of our switch boxes are centered on finished spaces. So instead of just nailing right to, you know, these 3 2x, we measured center of whatever the finish is going to be, and then we padded out accordingly to have their center of the switch box centered on the space.
I've been part of a lot of those walkthroughs, and you brought a lot to our attention as like, hey, this is what is shown on the plan, but I'm assuming you want this centered. Right. You know, one of the things was even on these big sliders, you know, I think at one point we had a floor outlet here that was going to be essentially, because this is so long, it's basically right at the cusp of like, do we need a centered outlet? But we opted to put one on either side on these wing walls. Right. And I think I remember you coming and saying, hey, this is what it's called for, but this is almost a better solution here.
So it's my job really to look at the plans. The elevations don't always match up with the rough power plans, and I have to kind of figure out what the intent is, what you guys are looking for, not just going and smacking stuff up where it shows, because it's not always right. We're talking about the difference of like a ½ inch. But to me that matters, because once this is all finished and closed up, I see that finished space and I see the outlet off center and I'm curling it in my skin. So like this space is 12'6" from wall to wall, in which case you do need a floor outlet. So we have wiring coiled up under the floors, because on our plans we had floor outlets, but we obviously went to the inspector and got special approval to not have those floor outlets, to keep your aesthetic nice and clean, keep these floor spaces.
And not only that, but like, you know, and I'm guessing why the inspector was fine with it, but it's like, that doesn't really make sense to have an outlet there anyway.
Right.
So like, it's probably doing more harm than good. You know, should someone be vacuuming in here, it's better to tie it back to the wall.
And what he just said to me was, you know, you're doing the best you can with what you have. Yeah. And that's what it comes down to, you know.
Well, that makes it sound like we put too big of a door in the wall.
But someone's going to live here, and it needs to be functional.
You know, one of the questions that came up in a video we posted before is you come up out of the wall and you loop, you're creating basically a heat coil. Because this wire, there's so much wire here, you're gonna get a hot spot on the wall, which I know isn't accurate. You just speak to that for a
so
second.
I mean, my cabling comes up through the floor, and all we're doing is one loop up and down. This one you're seeing that's kind of, it looks like it's doing a whole loop, but it's wires coming from different directions.
Got it.
So this one's doing a loop down, this one comes up and loops straight down, and it's all just leaving service loops. If I was to come up and do coil, and stuck it in the wall, then you're going to create some friction, because
maybe you could charge your phone on the wall.
Yeah. Wireless charger.
Yeah. I want to talk about the recessed lighting. We have 3 specs in this home, based on the fact that we have plastered ceilings, wood ceilings, and then secondary space, which would be like the basement and utility space. On these 2 floors, what spec are we using, and what are some of the things to consider when you're installing this?
So we have different specs, you know, throughout floors. Some sections of the floor are plastered ceilings, some sections of the floor are wood finished. So in this hallway space, we have plastered ceilings, so we went with the entres, is what was spec'd out. So these have a nice 3-inch trim that's spec'd out for plaster. If we walked into the kitchen space, where we have those exposed beams, these recessed lights change over to Elements, and they have a spec for a nice wood finish trim.
That's a product of just working with the lighting consultant and figuring out, you know, what spec do we need where and what adjustability do we need, but ultimately having the ability, or having the option to kind of down spec certain areas, so we're not, you know, overspending or being inefficient, and using what we need where we need it.
Right, so it just goes on to me making sure I'm looking at the plans and what the finishes are, and putting the proper lights up in the right locations.
I've seen it done a bunch of ways. Lasers, you're marketing on the floor and you set it, string line. How are you ensuring that stuff is where it needs to be?
So I'm using rough measurements off the floor, and then I'm lasering to make sure all my lights are in a perfect row. I'm also accounting for the finished walls and where they end. If I have 2 walls back to back, I know my sheetrock's coming in on both sides, so my center is true. Over here we have an overhang. So my finished wall on this side pads out 5/8 for sheetrock, and it also pads out 5/8 this way for the overhang, in which case my light has to shift 5/8 to accommodate the new true center.
And that's working with, you know, our team and the super on site, making sure, like, you know, you understand where the finishes are.
Right.
And a lot of that starts by doing the layout on the floor.
Right.
And, you know, things that come up are, you know, where the fire alarm is, where the duct work is, like all of that. It's kind of a careful coordination between all those trades. Let's go up to the second floor, because I know we have another panel up there. Why did we bring another panel? We already have two in the basement. What's the benefit of bringing one up here?
Yeah, so this was actually, I ended up, you know, pushing you to add this panel, mainly because it eliminates me having to get all my feeds from this floor down through the first floor and into the basement and wasting all that cable. So I went ahead and added a 100 amp feeder from the basement up to this.
Which is this black cable here, right?
Yeah, it's that black cable.
Rather than having a dozen or so Romex.
Right.
So this comes up into this panel, and then you're distributing the electrical from here for the second floor.
Correct. So all my feeders just end right on the second floor. We're not passing down through the first floor.
And similar design here, you have all your feeders coming in to your pull box, and then that comes into a single conduit into your panel.
Right, and then this will all get a Belkin plastered in access panel, so this will end up looking like just conventional wall space. You won't even know the panel's there.
So I want to talk about that, because that's something that I think comes up in a lot of projects. You have these second floor panels. Where do I put it? Hang artwork over it? How do I hide it? But we're using the Belco hinged access panel. When it is closed, you literally have this like 16th inch line, all plastered, all nice finish. How are we getting away with that, knowing that we have clearance issues?
So it was just working with the local inspector and seeing what he was requiring. Generally how it is the panel can't be recessed into the wall. So we're actually set back about a 1/2 inch in the rough framing. But where this panel opens up, the panel's right in front of you. You're not reaching into a cabinet, if you will.
Got it.
And he, you know, kind of interpreted it the same way, where it's just the wall space comes off. We're not in a cabinet.
Yep.
We're in a built-in cubby, and he was perfectly fine with that.
That's great. I mean, it makes your job easier by getting everything up here, and sometimes can be challenging from an aesthetic standpoint by working with the inspector and knowing what he's comfortable with. We end up with a pretty good result here.
Right.
There's a lot of like specifics on how we had to do certain things. The pocket doors was something that we had to consider, like working with, you know, thankfully we're working with 2x6 walls. You can see that I think you're using like a low profile metal box. You guys went as far as to not only keep the Romex flat for the aesthetic of it, but it also keeps it nice and tight against our panel here. So as our door is sliding in and out, it's not gonna hit.
All right, so our biggest challenge with any pocket door, so this switch requires it being in a pocket door, obviously with how the bathroom's laid out. So our biggest thing is making sure that when this door slides back into this pocket, that we're not scraping on the box and we're not getting hung up on any cable that's coming through. So this is how we were able to keep it nice and clean. It's drilling through the back side of the pocket door. You guys added that plywood for us, and we were able to staple along the plywood to keep it as flat as possible. And we ended up with about a 1/4 inch from the end of the back of our box to where the door is going to be.
Got it.
So we should be perfect.
This is something that you run into a lot with pocket doors. You just can't get the electrical detailing there. So I mean, that's a great solution, especially for the pocket doors. In the bathrooms themselves, we have floating vanities everywhere. So there's nothing underneath it. And then all of the bathrooms have floor heat. The floor heat is a Schluter product, which is the Dietra heat system. And then thermostats, you know, typically you want that thermostat accessible or in plain sight so you can adjust it. We typically set them and forget them. Yep. So we're not using the ambient mode. And that thermostat, we're putting in the vanity itself. So when we're making that request, what are the things that you're considering?
So I'm going off of, you know, what you guys want, what the eventual homeowner is going to have to deal with, and trying to make it as practical as possible. You know, so generally if we had a thermostat, we'd try to go centered up on any switch box we had about 5 feet high, so you're not bending down to hit it. Obviously we want to keep the space as clean as possible. Having the pocket doors is another, you know, challenge to overcome. So what we kind of decided to do was have these thermostats land within the vanities. So I have a 20 amp feed here that's dedicated for the floor heat that will get stubbed into the vanity, and we'll have a thermostat mounted, so when you open a drawer or cabinet, the thermostat's right there, similar to how a disposal on an under cabinet sink would work.
Yep. I noticed in the hallway actually you had these other cable trays. Can we walk back out there and walk me through that?
Absolutely.
Everyone's gonna ask, We strap our ceilings. We also do blue board and plaster, but that's a different episode. Our ceilings always get a 1x3 piece of strapping. It's just typical detail. I don't have a better answer for you. But in Massachusetts, I believe, correct me if I'm wrong, you can actually run your cable like stapled to your ceiling joist in between strapping.
Right.
Which for me is odd because there's this like 1.25 inch rule. Like when you're drilling through a stud, like you want to make sure that a screw can't hit it.
Yeah.
But you're not doing that here.
No, so 1.25 inch is the code, but then there's again a mass amendment that changes that to 3/4.
Got it.
Because when you have a 1/2 inch or 5/8 sheetrock, they're going to use an 1.25 inch screw. It's not penetrating the stud 1.25 inch because of that 1/2 inch or 5/8 lay.
Got it. Even though you're allowed to run your cabling in between strapping on the ceiling, you're not doing it. You're using, what are these called?
Yeah, so these are called home run helpers. So these are a great alternative to where we have this kind of dual level ceiling. It'd be really difficult to staple up to that higher level, and our ceiling space is so active with recessed lighting and air ducts and all that stuff that we kind of want it to be above the strapping, and then it gets more difficult to support it up there. They're like a PVC, and they have these 1.25 inch holes cut through, so you mount those and you can pull directly through them, and they act as your supports.
It probably makes it a heck of a lot easier to change something in the future as well.
Right.
We started this project and we weren't prepping for window treatments. We weren't going to spec anything. We'd come back to it. All of us at one point were standing here and we're like, this is going to be an awesome shower. How are we going to deal with this?
I said, there's going to have to be shades eventually.
Sure.
We're all open right now. We really should go ahead and pull these cables now so we're not cutting holes in finished spaces to add them later.
Prep for it. It's a relatively small percentage cost for the overall project for something that is likely to happen. Right. We know that these windows are large. You do have this one privacy concern here. So you want to make sure that you're prepping for that and giving the future owner, kind of peace of mind that, hey, we thought of that.
Right. And the cable's relatively inexpensive. What would be the expensive part is the labor. And obviously when you're open construction, the labor's a lot more efficient. You're not running through the attic. It's nice and neat. We were able to get all these pulled in one day.
I want to walk over to the primary. The one question that comes up, is lighting control. And frankly, it's a matter of opinion. In surveying our clients, 50% of them want it, 50% of them don't. Mm-hmm. A lot of people just want the ability to come in, hit a switch, lights go on.
Right.
So here we opted not to. But in terms of the way switching happens in consideration, like you actually brought up we had a few locations that, sure, it makes sense, like this room specifically, I can turn my lights on there and turn them off. You mentioned to us, like, how are you going to shut them off when you're going to bed?
Right.
So when you're thinking about, or you're looking at a set of plans, or even considering when you're wiring, what are those questions that you're thinking about, being that we aren't doing lighting control?
Yeah, so it all goes back to functionality. So I'm personally a huge fan of conventional switching just because it works.
Right.
Right. It's wired. You hit the switch, the lights turn on. There's never programming issues. Mm-hmm. Yeah, you might get a bad switch in 20 years.
Right.
But your problems are minimalized. The only downside is you have to physically have a switch at every location you want to turn it off. You don't have the ability to add those low voltage keypads. Mm-hmm. You could do picos. But we try to eliminate that. We can plan ahead.
Yep.
It'd be more if it was a finished space. You could add a pico later, but we want to kind of put switches where they need to be.
Is that a Wi-Fi switch?
Yeah, pico is a Wi-Fi switch by Lutron. So there's a smart switch you put at the actual load location, and then there's a battery-powered keypad button that mounts directly to the wall, and it gets a plate just like a Decora switch, so it ends up looking like it's in a box, but it's not.
And it gives you the ability. So like if someone were to purchase this home and want that, there's retrofit options to it, but we chose to, hey, it works, conventional switching, but with the caveat that we're thinking through functionality. And for example, in here, yes, we have a switch there, but we also have one over near the bed.
Right, so walking into this space, how big this master suite is, we have the doorway switches, and then you have the exit on the opposite side where there was a three-way from this side to that side. So you could turn the lights off and on from either doorway. Walking into this massive 20-foot long hallway, and then another 15 feet to your bed, now you're 30 or 40 feet from turning your lights off, to where you don't want to have to walk down the hallway and then turn the lights off to go to bed.
Right.
So we ended up adding 2 sets of 4-ways at each side of the bed to control all the lights in the master. So when you turn your lights on, you come in to go to bed, you can turn them off from the bedside.
So we have recessed lighting on the angle and the flat. What's the second switch for?
The second switch is accent lighting underneath all the windows. I believe the plans are going to account for a fabric panel.
Yes.
It's going to be removable underneath all the windows, and then the windowsill comes out and there'll be an LED strip tape kind of accenting that fabric, in which case we added our switch legs underneath each window. Because these panels are removable, we have the ability to put the drivers right underneath.
Yep.
And then just run our low voltage up to the LED, and you can access all these drivers really nicely.
This is a great detail to point out because the panels weren't actually designed to be removable. This was a collaborative conversation. It's, you know, talking about, hey, we have all this LED lighting, tape lighting underneath our windowsills. How are we going to run where do you want the drivers? And we think about like serviceability. If, you know, those drivers need to be replaced, sure, we could put them in the attic. Then you're climbing up there and figuring out what needs to happen. And I think we had a conversation. It's like, well, the best place is as close to the light as possible. And then we collectively said, then let's just put them there. And it was like, well, we need access. Right. Well, then let's make that panel removable. And I think that's what makes a good trade partner in a project like this, is that we're working through those details. You know, despite how much time we put into thinking this stuff through, there's always the evolving electrical code, the evolving building code, and frankly, just an evolving project. It's something that we all bring a lot of collective knowledge to, and ultimately end with a result as good as it will be. So if you guys are interested in building, fill out the form below. You can schedule a 15-minute call to talk about your project.